Okay, we're going to look at system equations now in 3 variables. So starting out with a little bit of a word problem. So we want to be able to first set up a system of equations before we solve. So a theater charges $50 per ticket for seats in section A, $30 per ticket in section B, and $20 in section C. For one play, there were 4,000 tickets sold, and it was $120,000 in revenue. And then there were 1,000 more tickets in section B sold than the other 2 sections combined. Okay, so there's really 3 things we don't know. And I'm going to use the A, B, and C for my variables. So A is the number of $50 tickets. B will be equal to the number of $30 tickets. And C would be equal to the number of $20 tickets. So the first thing that is going to help me out, I need to look at for some totals here. So it says 4,000 tickets were sold on one night. So that would mean that the number of $50 tickets plus the number of $30 tickets plus the number of $20 tickets should equal 4,000. Notice I didn't put any dollar amounts in here because 4,000 is the actual physical number of things, which is what our A, B, and C represent. So then if I have a second equation that has to do with money, so if A is the number of tickets sold at $50 each, 50A would be the amount of money that you'd make off of that group. And then 30B would be the amount of money made, and 20C would be the amount of money made with those C tickets. So then altogether, that should equal the $120,000. So it's like a money equation and then like the physical ticket equation. So I used up those totals. So then the last thing it says is that if there were 1,000 more tickets in section B than the other 2 combined. So the other 2 combined would be sections A plus C. And B had 1,000 more. So I don't want to add 1,000 to B, but if I add 1,000 to the combined total, that should equal my section B. So now a lot of people want to put the 1,000 with the B, but we already know B is big. And it said that there were more tickets in section B. So right here is our system of equations. So if you didn't get that, make sure you understand why that would be the setup, and then you should pause it and try and solve it, and then check back in. Okay, so if I'm going to solve this, one thing that I might want to do is rewrite that third equation. So if I'm like labeling these equation 1, 2, and equation 3, I really want the B and the 1,000 to flip-flop. So this would be A plus minus, I'm going to write it in order too, minus B plus C equals 1,000. Negative 1,000. So minusing the B over and then minusing the 1,000 over. That's how I got that. And so when I look at this, equation 1 and 3 together will already cancel out the B's. So if I combine equation number 1 with equation number 3 the way I rewrote it, I would get a 2A, the B's cancel, plus 2C equals 3,000. So I have one equation with A's and C's in it. So I need to have another equation that also has just A's and C's in it. So I'm going to take equation number 2, I have to use that, and put it with, well, equation 3 already has a negative on it, so that seems like a good one to use. So if I take equation 2, and that is the 50A plus 30B plus 20C equals 120,000. I want the B to cancel, since that's what's missing and what I canceled previously. So then from equation 3, I'm going to, again, use the one that had that negative in it. I'm going to multiply that by a 30. So if I multiply both sides by 30, that's going to get me equation 3 as 30A minus 30B plus 30C equals negative 30,000. And so together, equation 2 and 3 will now be 80A, the B's cancel, plus 50C equals 90,000. And so now the little system I want to solve is these 2 guys together. So that's going to help me find A and C. So I'm going to multiply, see the easiest number here, to multiply to get rid of the a's. Let's do that. So I'm going to multiply equation 1, 3 by a negative 40. I'm going to write it right below this equation 2, 3. So I'm going to get a negative 80a minus 80c equals 120,000, and that's negative. So putting, let's see, equation 2 and 3, and now again I rewrote equation 1 and 3. Putting those together, the a's will cancel, and the c's will be left with negative 30c equals 90 and negative 120. That is going to be negative 30,000. So if I divide by negative 30, I get that C will be equal to 1,000. So that means there were 1,000 of the $20 tickets sold. Those again were the $20 ones. So if I want to find out the number of C tickets, because again I'm solving just this little equation, A tickets, I'm going to plug in to one of those original guys. Let's just plug in to that first guy, just make it easy. So 80a plus 50 times that 1,000 is going to equal 90,000. So 80a plus 50,000 will equal 90,000. If I subtract the 50,000, kind of short on room here, sorry about that. Then I'm going to get 80a equals 90 minus 50, that's going to be 40,000. Divided by 80, it ends up that A will be equal to, that would be 500. So we're going to have 500 of those tickets. So I have 500 of those plus 1,000 of the other guys. Now, at the very beginning, if you look back, equations 1, 2, and 3 have all the variables. So I'm going to start with the simplest one, equation 1. And it says that if I take the number of A tickets, which is 500, plus the number of B tickets, I still don't know about those, but I do know the C tickets were 1,000, that will equal the 4,000 total tickets sold. So 500 and 1,000, that's 1,500 plus the B equals 4,000. So if I subtract the 1,500, it looks like B will be equal to 2,500 tickets. So that would be 2,500 of the B, again I'll highlight 1,000 of the C, and 500 of the A. Okay, we're gonna look at number 2. So number 2, I'm just gonna put the answer out there. This is supposed to be 4, 3, 1. So if you got that, awesome. If not, let's see what happened. So I'm going to label these equations 1, 2, and 3. So right away I look and I see equation 1 and 2 have a z that will cancel out really nicely. So if I put equation 1 and 2 together just by adding, we're going to get an x plus a 4y, the z's cancel, equals 16. So next what we'll want to do is put together equation 2 and 3, but we have to cancel the same z. So in order to make the z's cancel, I have a negative 3z. That would have to have a positive 3z. So I'm going to multiply the second equation, both sides, by negative 3. That will do it for us. So let's write that down. That will be 3x minus 15y plus 3z equals negative 30. So that's my new equation 2. But I'm going to bring down equation 3. That's going to be 3x plus y minus 3z equals 12. So when I combine those guys together, my new equation will be 6x minus 14y, the z's cancel like we wanted, equals, we'll have 18. Well, actually that would be negative 18, negative 30 and 12. So now we're going to take the equation 1, 2 that we made and the equation 2, 3, and we're going to try and solve that little system. So that's just x plus 4y equals 16, and then 6x minus 14y equals negative 18. And so I don't really see anything that's going to cancel right away, but if I multiply the top equation by negative 6, that would make my x's cancel. So bring that down. That's negative 6x minus 24y equals negative 96. So the x's cancel, and we'll get a negative 38 equals a negative 114. So this is negative 38y. If we divide by the negative 38, divide by negative 38, we get y equals positive 3. And so again, we're solving just this little system, so we want to plug this back into one of these equations that we just created. And I'm going to plug it into just equation 1 and 2. It doesn't matter, either one, you get the same answer. X plus 4 times 3 equals 16. So x plus 12 equals 16. Minus the 12, we get x equals 4. And so we've solved the little system. So then we have to go back to the original, plug into equation 1, 2, or 3. I'm just going to use the very top equation, which was 2x minus y plus z equals 6. So I'm going to plug into that. 2 times the 4 minus the y we got was 3. And then plus, we're going to find out z right now. So that will be 8 minus 3 plus z equals 6. 8 minus 3 is 5, plus z equals 6. Minus 5, we get z equals 1. And so in order, x is 4, y is 3, and z is 1, like we said. Okay, so just to start this one, there's actually no solution to it. So if you got that, awesome. If not, let's try and figure out why. So we have equations 1, 2, and 3. So just looking at it right away, I notice, let's see what looks kind of nice. I could try and eliminate, look at equations 1 and 2. I could try and make z's cancel. So if I multiply the second equation by 2, the top equation is still the same, 4x minus y plus 2z equals 1, so that's equation 1. Equation 2 now would be a 6x plus 10y minus 2z equals negative 4. So when I combine those together, that's 10x plus 9y equals negative 3. And so I want to get rid of the z on equation 3. So if I look back now at equation 2, if I multiply that by a 3, that will make my z's cancel. So that will become a 9x plus 15y minus 3z equals negative 6. And equation 3, just keeping that the same. So that's equation 2 changed, but equation 3 became negative 9x minus 15y minus 3z, oh not minus, plus 3z equals 0. So that one stayed the same. So now when I put these two guys together to make my new equation 2, 3, wow, everything cancels, cancel, cancel, cancel. So I actually have 0 equals negative 6, which is not true. So when you're solving and all the variables cancel out and you have something that's not true, then right away we know there is no solution to that. And so we'll say this is an inconsistent system. All right, let's look at equation system number 4. So if you're looking at 4, if you got infinite solutions, then you got it right. If you didn't, then let's see what happened. So there's infinite solutions, and they are dependent then. So let's see. If I look at equation, what do we want to look at? We have 1, 2, and 3. So actually I notice on equation 1 and 3 that they are like multiples of each other. So like if I wanted to cancel out the x's here, I'm going to multiply the top equation by negative 3, both sides. So I'm going to negative 3x minus 6y plus 9z equals negative 15. That's my equation 1. Equation 3, let's keep that the same. 3x plus 6y minus 9z equals 15. And so when I put those together, cancel, 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 0 equals 0, which is true. So if I'm going to get something that's true, then I know that those are actually the same plane. and we're going to get an infinite number of solutions. And so this is a dependent system.